Okay, so this is going to be the finishing the equipment activity video. And before we go on to number 27, which is hot plate, I want to talk about beakers one more time. The video was super fast on all of this equipment, so definitely go back and pause things as necessary if you need to. But beakers, one common mistake that people make is that they think that they're for measuring volumes of liquids. Now, they have these nice little measurement lines on here, but these are completely estimations. If you look at this one, let's see if I can get that. It even says approximate volume. So what I want you to do is in number 7 on your activity, which is beaker, I want you, whatever use you wrote is probably correct, but I want you to add to that, not used for measuring volume. Not used for measuring volume. Okay, so that's going to be really important. We want to make sure that you understand that. We want to use more accurate tools that are narrower and more precise on their measurement lines, like a graduated cylinder. Okay. All right, so this is a hot plate. So number 27, hot plate. This is what our hot plates look like. They have a little power knob. You can rotate that to turn it on. This light is on whenever we plug the hot plate in. This light is on when it is actively heating. So when we turn it on to high, for example, this light will be on for a while until it gets to its highest temperature. And then that light either turns off or starts blinking, kind of depending on where it is. Okay. When we use beakers to heat, this is a much easier way to use a beaker for heating. So we're going to use this instead of a Bunsen burner. We don't have to set up a ring clamp or anything like that when we're using a hot plate. It's a lot easier. Bunsen burners will save for heating things that have round bottoms or things that are ceramic or things that we need to get to super high temperatures. Okay, the next one, number 28, is a watch glass. These are watch glasses. They're like little curved plates. They kind of are contact lens shaped, and they come in a couple of sizes. And we're going to be using them for a couple of things. One, you can take one of these and you can cover a beaker with it. So if you're trying to heat something without boiling it dry, for example, we'll use that as a lid. Another thing that we'll use this for is we'll put one of these on a scale and then we'll scoop powder onto it so that we can measure the mass that we need for an experiment. That way we're getting it onto a little plate instead of directly onto the balance. So those are our watch glasses, lids, or dishes for use on a scale. All right, next one, number 29 is a Beaker burner. So over here I have a setup. This is a ring stand with a ring clamp. It has a clay triangle. It has a crucible sitting in the clay triangle. A Beaker burner is a much more intense version of a burner than a Bunsen burner. It has a much higher temperature flame. So when we use crucibles, which by the way are used to superheat solid materials, we don't put liquids in crucibles. We put solids in there. We superheat them to drive any water out of the solid that we can. And we will be doing this in a lab in the spring semester. But Beaker burners are used for superheating crucibles. Okay. Now, since I already have this set up, I'm going to review the crucible tongs here. So these are our crucible tongs. They're metal. They have this weird shape. This little opening right here is something that often people assume is used to kind of wrap around a crucible, you know, like kind of around that crucible. But it is not for that purpose, okay? So I don't know why they're shaped this way, but the more stable way to use tongs is always pinching. So what you would do is you would take one tong, put it inside the crucible, one tong on the outside of the crucible, pinch, and then lift up. That is the stable way to carry a crucible and to use crucible tongs. We do not use this curvy area for any purpose. It is not for wrapping around that crucible. So let's not do that because that's a really easy way to break an $8 to $10 piece of ceramic. Okay. All right. After that, on your sheet, you should have a B-roll pipette. This is a B-roll pipette. You've probably used them in science classes before. Sometimes, like this one, we'll have little measurement lines around the, hard to focus, but there's measurement lines in the stem of the pipette, okay? But we just squeeze and put it into a solution. We can draw up, it is not like in my hand there, we can draw up fluid, solutions, water, whatever we need, and then we transfer it over to another container. Okay, so that's a B-roll pipette. They're cheap. They're not super accurate in measurement, but we can use them to transfer things dropwise. And then 31 is a Microwell plate. So this is a little dish. It's plastic. Sometimes they come in ceramic as well if we need something to be a dark color or a light color as a background to what we're making. We will use ceramic Microwell plates. But these little wells are just small wells. And so, for example, we might use our pipette to add drops to a well, and we'll do small scale mixing chemical combination experiments that way. And then finally, you've all used a thermometer before. These are our thermometers. They are made out of glass. They have measurement markings in Celsius, and the red liquid inside is alcohol. It's an ethanol-based thermometer. Mercury has been banned from being used in school thermometers for quite some time. So that's number 32. All right. And finally, we have number 33, which is a fume hood. And I'm going to back up here. So hi. So this is the fume hood for our classroom. It is a chamber with a glass door. This glass door can be lifted and lowered just by pushing and pulling on it, okay? It is designed to keep you safe from any fumes that you might have from an experiment, either using concentrated acids or from a combustion that's creating a byproduct that you don't want to breathe in. We turn it on with this red switch right here. We'll listen to that. And that pulls any fumes that are being created or released by our chemicals up and out through a filtration and out into the outdoors instead of allowing that stuff to get into the classroom and to affect us. So we will be using this periodically depending on the chemicals that we're using or the demonstration that we're doing. So that's the end of the descriptions for your activity. There are some post-activity questions. Make sure you answer that page of questions, and then you can submit pictures on Canvas. Thanks.